Greetings from Paris and welcome. Thank you for joining us. This concluding panel to the World Satellite Business Week is going to explore the absolute cutting edge of the geospatial industry and some of the most exciting things that the industry is doing. I am joined today by Steve Hamburg of the Environmental Defense Fund, Stefan Germain of GHGSat, Antoine Rostand of Kayrros, McKinney of Descartes Lab, Philippe Briscoe of Rezatec, and Gareth of Terrabotics were going to explain to us the many things that their companies are doing. I will start by referencing a book that recently came out that I'm really looking forward to receiving, called The Knowledge Machine by Michael Strivens. It's in part on how the scientific revolution in the 17th century was about taking seriously some absolutely infinitesimal phenomena that had previously escaped human attention, but that turned out to decide much of our lives, and on how research requires a degree of obstination that's maniacal and not quite human. So we fit in the long tradition, since this panel is about tracking tiny changes, and it happens some of your research staff, gentlemen, is not human because they're AIs. We will first talk a lot about environmental monitoring, which as a field of research and business is absolutely exploding. And of course, one lesson of recent months is that Mother Nature talks softly, but that after a while, she can punch pretty hard if she's ignored. We ignore the forces of nature at our peril. However, this is a business conference, and from this angle, weak signals and distant rumors are also extremely precious commodities to the traders, and that is what we will explore in the rest of our discussion. But let's turn to our first theme, which is methane detection. It's an absolutely existential topic because of what the methane that we allow to leak into the atmosphere from various industrial processes and actually from nature itself can do to us if we ignore it. In business terms, allow me just to set the context to note that 2 months ago, the French government vetoed a $7 billion contract to purchase American natural gas because the gas, if it's produced without control, is considered too harmful to the climate to be allowed into the marketplace, at least by responsible buyers. Now we will hear about some of the tools that you are arraying against the problem and to help the energy industry do its part, hopefully to everyone's benefit. So Steve Hamburg of EDF, why don't you start and set the scene for us, please?
Thanks very much, Stefan, and share my screen here. And thanks so much. It's a real pleasure to be here. I want to begin by talking a little bit about the context of what we can measure on methane emissions. And it's important to note, as Stefan said, methane emissions account for 1/4 of the current warming we're experiencing. So it's a big deal. It's having a big impact, but it's also an incredibly potent greenhouse gas that can be, because of its short half-life, if we stop emitting it, we see the positive benefits on reducing the rate of warming. So if we think about the different types of measurements we can make from space, there are basically 3 types of instruments: mappers, target mode, and hybrid. And I'll come back to that in a minute. And the types of data that we see are radiant spectra, which the science community takes, which then produces the atmospheric column methane concentrations. That's what most of the data all the data almost you're seeing now currently. But really what we need to get to is geographically defined methane flux rates. And I'll come back to that as well. There are several key characteristics that matter: swath width, spatial pixel size, the precision of the instrument, and then putting that all together to get the detection threshold. I mention this because this is an incredibly dynamic ecosystem where we're getting better and better every day, but it's important to keep these variables in mind, or we do get a bit lost in trying to understand how to compare and contrast. In terms of the different instruments that are out there, the leading mapping capability is through TRUPOMI, an ESA, a European Space Agency Sentinel-5 based instrument that was launched about 3 years ago. It's a very wide swath, large pixel size with a fairly good precision. Target mode, we will hear about GHGSat from Stefan next, which is basically a smaller swath, smaller pixel size that can allow us to see specific points, but not the whole area and not quantify all emissions. The hybrid is MethaneSat that we will, and I'll talk about in a minute, anticipate launching in 2022. 200-kilometer swath, a much smaller pixel size than Tropomi, but larger than GHGSat. There's also a series of research instruments that are flying now that can be useful, but aren't able to produce the mass data, and I won't talk about them now. We need to think about the data, and we'll talk about AI and some of the leading companies working on it as a moving from data calibration, which we currently produce, to methane concentrations, which a Tropomi can produce now, and what the satellite community is producing. But we need to go past that with the AI to getting gridding and geolocation, and ultimately to methane quantification of all the data, which is currently not available, is what we are building into the basic mission of MethaneSat. This is just an illustration from the Permian. It was reference to the LNG case in France. We're using Tropomi data, the full inversion on the left-hand side, the infrastructure mapping that was done by Descartes Lab with EDF, producing then the full inversion. The left is concentration, on the right is the actual flux rate, the amount of emissions spatially defined, in this case for 11-month period. That's the data we need to have policy relevance and action. And then I'll end with MethaneSat mission is to be able to do that even better. We're launching in fall of 22. We will be able to produce full inversion data as the base product. As I mentioned, it's philanthropically funded. The science team is at Harvard University, the Smithsonian Astrophysical Observatory, and EDF, and it's operated by MethaneSat LLC, an affiliate of EDF. And with that, I will thank you very much and turn it over.
And so with that, we move to Montreal and Stefan Germain of GHGSat.
Thank you, Stefan. So GHGSat uses its own satellites to monitor greenhouse gas emissions from industrial facilities around the world. With the launch of our latest satellite just a few weeks ago, GHGSat has again advanced the state of the art in satellite monitoring of gas emissions. We're now detecting much smaller plumes and are well on our way to detecting a 10 times lower detection threshold than our demonstration satellite. We develop analytics using our own data and third-party data to provide valuable insights to our customers, such as predictive analytics, hotspots, and actionable recommendations for our operators. We also committed this year to make our data and expertise available for free for public good. And the result is what you see on the screen here, a map called Pulse. So Pulse shows concentrations now, but as Stephen just said, emissions is really where this needs to go, and we're working hard on that for 2021.
Stefan, so allow me to jump in here. On the world map, one thing that kind of jumps at you is those hotspots around Greenland. Is that the permafrost going away before us?
Well, I'm going to focus on areas of the map I can speak to directly, which is related more to industrial activity. The areas that you'll see where it's very likely not industrial, but probably more biogenic or thermogenic methane that's being generated, I have less direct experience to speak to. So I'm not going to make a statement on whether or not that's melting permafrost.
Okay. Fair enough.
Sorry to be boring, but I'd rather stick to things I know and can back with facts. All right. So as a specific example of our capabilities, consider this large leak that was reported in May of 2020 in Florida. We've been working with Sentinel-5P or Tropomi for years. We even wrote a paper in 2019, co-authored with the science team at ESRON, the Netherlands Institute for Space Research. And using this data, we are able to identify, like many others, actually, this leak in Central Florida. And the issue at the time with Tropomi is it wasn't able to be attributed to a particular facility. But there are other satellites, like Sentinel-2, for example, that can be used using common methods to attribute the leak with high resolution to a specific facility. So what you see here is actually in the middle panel and right-hand panel, a plume directly detected by Sentinel-2 and presented, overlaid on the facility on the right. So we validated these techniques with our own satellite, and we're going to continue to make this kind of information available for free. So we are writing a peer-reviewed article as we speak that'll be showing the methods that were used to develop this, and all of that will be available for free. So last slide, no single technology can do it all. We bring GHGSat brings together unique measurements and analytics to deliver value for our customers. We combine multiple satellites and aircraft sensors to monitor the small number of sites, in this slide about 5%, that are responsible for the vast majority of emissions. And on this particular study, it would show about 90% of emissions from oil and gas. Globally, of course, we also monitor dozens of much larger sources, but frankly, these require non-commercial solutions. So we bring all of these together, all these capabilities and measurements and analytics to deliver that value for our customers. Thank you, Stefan. With that, I'll hand it back over to you.
Thank you, Stefan. And having heard from the satellite operators, now we move on to the analytic companies. And let's start with Antoine Rostand of Kayrros. You have to unmute yourself, Antoine.
Yes, sorry for that. Yes, so the idea is to show one of the main value creation through AI and space, which is climate action on methane. The concept that we are developing is what we call visible methane, where we integrate the detection and quantification capability of Sentinel-5P with activity detection and attribution of other satellites. There are many satellites that can see methane, in fact, including Sentinel-2, but many others. So from that, we can attribute methane leaks to very precise location, even though it's difficult to quantify. And then we apply AI to create a map of the world of large methane emission that can be attributed to specific assets and specific polluters. So that's really what we want to do at Kayrros, so bringing the AI that is needed to transform satellite imagery into something that can be used by decision makers. The good thing that has been approved by the regulators here, it's a tweet from the European Commissioner on Energy, putting our map of emission with the idea to remove all super emitters from the energy supply chain in Europe. So this kind of AI plus hardware is going to have an impact. And it matters because we see a lot of these large leaks. It's it's equivalent of 1 gigaton of CO2 per year, and most of these leaks should not happen because these are just operational negligence and not a normal course of operations. And I'll give a few examples. This is a leak in Iraq, 447 tons per hour, 700 kilometers long. We have seen one leak in Algeria, leaking since 2017, at 20 tons per hour plus. We have leaks in the US, 150 tons per hour, something like 50 miles south of Chicago. So and there's quite a lot of leaks on US pipelines. And like in Europe, because of the procedure for maintenance are very different. Here you see maintenance in a Russian pipeline. You see two plumes. It's just a two valve station that have been opened at the same time, 30 miles away. It's very characteristic of the maintenance. Again, there are ways to avoid releasing this methane in the atmosphere. Coal mines. So, you were mentioning this French government blocking. Clearly we've quantified the visible methane intensity of various sources of energy in Europe, and there are a lot of differences whether you, import Russian LNG or US LNG. And from that, we can create a ranking of utilities depending on the energy they consume. So, which means that consumers will now be able to choose their energy provider based on their visible methane intensity. We know it's not all methane, it's only part of the methane, but at least this is the methane we can see today with existing technology and algorithm. And I think our common mission all together with EDF, GHGSat, and all of us is to make sure that all these super emitters are eliminated within the next couple of years, because they should not happen. These are just operational negligences. And if we send the right signal, they will be eliminated.
Right. Yes. Very powerful examples for the policymakers who may be watching this. The oil industry normally does not reward negligence, and so this is largely about making them implement their own rules. Let's move on to Ryan McKinney of Descartes Lab, all the way from Santa Fe, New Mexico. Thank you for the very early start.
No problem. And thanks again. I'm happy to be here. I'm excited about the opportunity to speak with you all. And again, Ryan McKinney, I head up our partnerships for Descartes Labs. And that really stems with all of our data partners, part of our data strategy, as well as the value-added partners where we work with folks that provide the outputs that lead to this actionable intelligence for not just our government customers, but also our enterprise customers. We're, as you mentioned, Stefan, we are based out of Los Alamos National Lab, which is just north of Santa Fe, New Mexico. Our big focus as a company since we started back in 2014 is really our focus on providing automated analytics at planetary scale. As you can imagine, methane is certainly something that's become a topic and a concern, not just for governments, not just for regulators, but also for large enterprise companies that are responsible for global supply chain and folks that need to make sure they incorporate the insights that come out of this. We've been successful and want to continue to be successful by providing these unique operational insights to our enterprise customers, really by enabling them to make business decisions from this multimodal customized model for their business. That's really what we want to focus on, and we look to make sure that that's the value the customer gets. Leveraging that global scale multimodal data is really what turns into that foundational element where then the higher resolution capability, higher revisit capability begins to be how they start to make changes to their policies or make changes to their operation. We want to be able to work with our partners to provide that and to help escalate that. The unique piece to Descartes Labs, oftentimes the folks that we work with are never actually taking the data in raw form and using it in that form. Typically, it's a derived output combined with multimodal global scale data that provides them the insights they're looking for. So it's much different than just looking at a pixel and deciding where you want to go. And I think that's why we're here. But I think that's going to continue to be the trend that we see, and certainly what we're trying to do to support our customers. Combining these foundational building blocks and being able to add on top of that optical and SAR and really tell the full story, I think we have an opportunity to make a huge impact and continue to bring awareness to how we need to address this. It's just a shameless plug on the partnership side. There's a renewed interest from Descartes Labs to really find ways to collaborate with data providers and value-added partners, subject matter experts, to continue to drive that innovation and put that actionable intelligence into the hands of the users that need it most. But I'll go ahead and stop there, and thanks so much.
And thanks, Ryan. So that widens the discussion a little bit already to some of the many other industries which you are touching. Let's continue with Philip Briscoe of Rezatec.
Thank you. Share my screen. So Rezatec is really focused on the interpretation, application of satellite data, in the kind of downstream environment. So we operate in an area we call geospatial AI. So it's really taking all sorts of different data sets, of which satellite data is one of those components, but we're also looking at environmental data sets, we're looking at asset data. And we're really helping our customers have better insights into the way that they manage essentially their assets, so natural and man-made assets and critical infrastructure. So this includes utilities, forest owners, farmers, all sorts of different stakeholders. But essentially, where we're providing the value to these organizations is through the benefits of using space data, satellite data, so able to look remotely, especially when you look at current challenges we're seeing from COVID through to climate change. I mean, the need to be able to monitor and measure things remotely probably never been more relevant, but also at scale. Of course, satellites are very good at looking at things at scale and also doing it in a more cost-effective manner. And that's really what we are looking at when we talk about geospatial AI. Just to talk a bit about where we apply this. So we're based out of the UK, but we work with organizations all around the world. We're really helping them to, as Ryan was saying, provide actionable insights based on interpretation of all sorts of different data sets, and increasingly using artificial intelligence in the way that we do that. So to give you a few examples, in forestry, for example, we're able to look across millions of hectares of forest and identify things like spruce beetle infestation, which have a devastating effect on forests and the bottom line, and identify them early using artificial intelligence to identify those patterns, those relationships that enable foresters to go in, get the timber out, get a salvage value, and stop the spread. So with all of our applications, it still comes down to a return on investment. You've still got to have a payback model that works. And then looking at utility providers, so in the energy space, we kind of use our vegetation experience to look at things like risk of vegetation intrusion, looking across really remote, long-distance transmission lines, for example, and identifying where organizations need to apply their ground crews, put in place inspection and mitigation activities. And all this is more cost-effective than traditional ways of doing it. Similarly with water operators and owners, so those people operating dams, for example, if you're trying to manage 100 dams across a distributed area, then using geospatial AI in order to do that, in order to proactive, and this is the difference, this is what this sector's allowing these sorts of organizations to do, is be far more proactive in the way that they manage their assets. So instead of identifying a leak after it's happened, or identifying an issue when it's too late and too expensive, what we're doing using predictive risk, using AI, is identifying where the likelihood of failure is, where should they focus their resources and investment. So just an example of some of the types of sectors that are using these sorts of new techniques. Yeah, I'll hand back to you.
Oh, okay. I thought there was one more slide. And let's finish the lineup with Gareth Morgan of Terrabotics.
Hi there. Thank you, Stefan. Thanks. Good to be here with you all on the panel. Right, sharing my screen, I think. Hope you can see.
We see it.
Great, brilliant. Yeah, so thank you. Good to be here with you all. Terrabotics is an Earth observation satellite data analytics company that is probably quite unique in the fact we purely focus on the natural resources sectors, particularly energy, oil and gas, and mining. And that is our customer base, the super majors, the big mining companies, the big oil and gas companies, right down to the small operators. And it's our mission to shine a light on these often opaque and complex supply chains that are globally distributed, very complicated, yet are supplying the vital natural resources that we all need and rely on. So it's our mission to use the growing satellite data and variety of sensor types, which is exciting to be being able to, in recent years, bring in the gas emissions alongside optical, radar, laser, LiDAR missions, thermal, and fuse all of this data together in order to solve problems for these sectors and create greater transparency for all, including the companies, the operators, the investors, pension fund holders, the regulators and the governments. And what's been driving us lately as a company, we've been operating 7 years now, as of this month, 6 years commercial operations. But the big driver going forwards for us is the ESG sentiment, the environmental social governance that has taken over the investment world, the pension funds. And we're seeing that drive the companies, the oil companies themselves, to jump to action to do things about climate change much faster than the regulation can act. which is interesting and has its own complications and things to discuss in itself. But we've been pretty astonished to see how the super majors in particular have had to respond to their investors saying you must adhere to the climate agreements, and the impact of that as it's come to us, who already operate with all of the super majors and all of the main oil companies. And we've started to develop solutions and test solutions with those companies over the last few years. And that's been a really interesting outcome of this, and exciting for the future and for the discussion of what we'll have on this panel. So for us, it's about all of the contextual data, a bit like some of the other panelists have said, to bring the optical data, the radar data, and provide the context that's key to adding to emissions. And it's not just greenhouse gas, methane emissions in our view, it's all of the gas species and the cocktail of gas species that we can bring together and use to essentially verify what is reported by companies for themselves and for what the regulator sees. And this is really an exciting area going forwards. And this is the focus for Terrabotics. And we bring it all together to supply information to both the operators and eventually the regulators. And I'll just finish by saying it's a complicated thing. It involves the AI, but physical models, a lot of expertise, a lot of knowledge, and you've got to bring it all together. And that's why Terrabotics focuses on the natural resources solely, because that's our background as founders of the company, as team of the company, will come from this sector. And so we apply it to a sector we know well and know how to operate in. And there's a lot of work to do.
Excellent. Thank you for those introductions. Let's spend a few minutes digging into the methane thing. Let me ask you first of all, who's the customer today? We've heard a lot about the regulators following this. EDF is a non-profit. It would be nice if the energy industry took custody of the problem. They are, after all, the good people in Texas and Louisiana, and need no introduction to global change these days. But it still looks like the data provided to people with a stick, who then take it to the energy industry. Are you already seeing the oil and gas and mining companies come to you saying it's also for us to, as you said, make our process more efficient and improve the bottom line? And by the way, combine the two, not being hit by fines, reducing damage and improving our operations. Are we there yet? Yes, Stephen.
I think we're beginning to get there, but we have to remember that this is just emerging. So we, over the last 10 years, have been producing a large data set on these emissions, but for the most part, they were not understood prior to that. And because we still can't quantify total emissions from remote sensing, and this is an important point, and where I will maybe disagree with Stefan a little bit, there is not, the bulk of places the super emitters don't account for 95% of the emissions, quite the contrary. So we have to be very careful. We're building a picture, but we still can't describe the full elephant. We're seeing parts of it, and the industry is responding. OGCI companies have made commitments to hit much lower emissions rates, which is fabulous. But with that, the picture of the emissions is still emerging, and that's why we need greater capacity both on the technical side for the remote sensing and the AI side, and that's why the fabulous group of people here who are pushing that envelope.
Yeah, sorry, go ahead, Gareth.
Please, I can see a discussion. I was wondering, let me inject something into this debate, which I see is starting. It's a lot of satellites, it's a lot of sensors. Are we going to see a battle of the sensors, which could confuse the market and the end users if it's not managed properly, and could take us back to the situation where we've been for 2 decades with CO2, with people arguing on what the data meant and using that as an excuse. Stefan.
Yeah, I can jump in there. So first of all, the more satellites, the better. Right now, everything that's up there today complements each other. And even what's planned, including what's imminently going to be launched, like MethaneSat, is still going to be complementary. And we need more satellites to provide more persistent measurements. So I don't think there's any issue right now with the oversupply of satellite data for methane monitoring, not at all.
Yeah.
And I would argue there's a strong commercial demand for this right now. There's clearly a lead from the oil and gas industry. I've got multiple customers in the areas that have been described, like the Permian Basin, for example, right now, signed contracts, revenue generating contracts. And that's the oil and gas industry themselves that want to understand the kind of emissions they've got so that they can act on them and reduce them. So I think that this market is here now.
Yeah, one of the things we're seeing from our oil and gas and our mining customers is an absolute interest in understanding, what is out there today. And again, to Stephane's point, I don't know of an AI company who will ever say there's enough data. So the more the better. Keep sending it up. We'll keep using it. But I also think, one of the big challenges, and I think this is a similarity across all of the potential consumers for this data, is the real need for historic data. I mean, in order to understand what the impact has been, you need to know where you started from. And so I think, that's going to be a challenge. But I think as we begin to expand the sensors, look to combine terrestrial sensors, look to combine all of this information together, we can begin to tell the full story and understand what the impact is, whether good or bad, from those sensors.
Yeah, I'd like to just touch on those points as well. Firstly, more data, the better. I think we're all in unanimous agreement there. The more data, the more sensors, and more variety of data types as well. Not just one species of gas, like I said earlier, but everything has a story to tell of how things evolve and helps us create our models. So the more the better. Always on would be ideal, always on. And we can build up that 2-year archive that you probably need to convince anyone that this data is good to use against their existing non-space data sets.
So more data is better. I think everyone seems to agree on that. And who would disagree with that, really, if they are ingested properly? Now, the energy industry for a long time they had geologists who knew what to do with geological maps. I guess where you are, you have the finger on the pulse of that industry. I'm sure they're getting a lot more sophisticated. Many of them use AI already for exploration. Are they still learning how to use the satellite data that you're providing, or are they catching up with the master in many cases?
Yeah, I can speak as a former remote sensing analyst within a super major. Started in 2006. It was very much pixel pushing in those days, and then we get to the point now where I couldn't do my job with the data we have today. It has to be automated. It has to be analyzed. But what you see is generic data science teams being developed to data science everything, every corner of the business, and you need those specialists to do it, and it will take time to catch up. Conversely, the super majors can afford it, but they don't have the focus to do this sort of specialism.
Right. But then there's all the others, and there's
to have the team.
And we've been watching the oil industry also from the standpoint, we don't have to discuss this, but from the standpoint of the digital oil field and telecoms. And this is still an industry where you read in trade publications that I don't need to put sensors on the pipe to find if it's overheating. I can put my hand on the pipe, and if it's hot, I know there's oil inside. So there's a learning curve. Imagine what that could be in some of the other emitters that exist out there, such as landfill operators, for instance, which I know some of you are going after. I'm wondering what the conversation could be like between remote sensing AI company and landfill operator. Does it connect? Are they getting on board? Landfills produce methane, right? Yes, Antoine.
Yeah, so for landfill operators, we do two things. We do 3D reconstruction at scale, so that can replace, is more cost efficient and more accurate and much faster to compute than drones. You have a few centimeters of vertical resolution with 3D reconstruction. So that's something that we do. And for methane, the current sensors are, a bit, not sensitive enough, but if you average for wind and something like that, you can start to see and quantify some methane on the large landfills outside of Europe. So we start to see things, and obviously, once we have MethaneSat, we'll be in a much better shape. But we start to see emission from large landfills with a proper algorithm.
Right. Stefan, I saw you react on landfill.
Yeah, I can just add that, so we're seeing emissions from landfills today. In fact, there'll be a peer review publication on that very shortly as well. We have commercial customers for this as well. And to your point, there's a learning curve. And I think we're seeing the same thing in oil and gas as we are in landfills, as we are in coal mining and other industries with emissions. The large operators who clearly have an interest in their brand and social responsibility are taking the lead. And we're seeing that in landfills as well. Large operators have small teams, but have the technical know-how to ingest, whether it's aircraft, drone, or satellite data, to then compare that to their ground measurements and see which is most cost-effective for them and most accurate. And so there's definitely an appetite there.
Sanitation is one of those huge industries that has been very, very far from the satellite industry. If they're getting on board now, it's something of a sea change in the market. Ryan, is that?
Yeah, well, and one of the things that we see from our customers, and one of the value adds that I think all AI machine learning driven companies can provide to the customer is, oftentimes geospatial data is complex. It can be messy. It can be hard to ingest. But I think if you can make it easier and you can clean the data to the point where it becomes science ready, I think you'll continue to see the adoption of the use of that data in a lot more use cases. And I think that, that's one of the responsibilities we have, is to make sure that that data is really put into a digestible format and put in a way that it translates into their individual business or the individual use cases that they're concerned over. So I do think there is a learning curve. It's exciting because I think people are really wanting to tackle this. And I think part of our job is really to make the data usable beyond just, maybe one or two individual use cases.
So science ready, the words have been uttered. Do you have any messages for the satellite operators out there? Because very often the AI analytical companies would say, I cannot use those pixels. They're not properly calibrated. Some of them go so far as to build their own satellite, which is an expensive thing to do. Is the people who build and launch the satellites, did they get the message? Or can you work with imperfect data, maybe? Who wants to take that?
Let Stephen talk first, and then.
Yeah.
So I think the answer is, one, you can work with imperfect data. I think we've seen great examples of using what we have now, which is much more than we had, but much less than we need. And I think what we have to recognize is that and it's been mentioned, but I just want to iterate it. Antoine, Stefan said it, Ryan, is that we're on a learning curve. It's going to take us a couple more years, but not a lot more than that, to be able to really fully understand the issues we're talking about. And we have to recognize that the industry overall is very, very early in their understanding of these issues and use of this data. We do not, and so we have to be careful. So, example, I'll go back to what I said before. Most of the data does not give us flux. We're building those algorithms now, and we heard numerous examples, but we're only in the early stages. So again, I will plug MethaneSat. We're the first mission that built into the mission the development of full inversions as the data product. It's the only mission that has flux rate, amount of emissions, as the mission product. We have great examples on the stage of people who are taking the data, ingesting and building the algorithms. So we just have to remember we're on a journey. We've got an exciting point in time. The ecosystem is growing, and as Stefan said, we can use all the data we can ingest, but we're not there yet, but we're getting close. And we have to think about what the data quality is at each step so we don't oversell it, but we maximize its utility.
Okay, Antoine. And folks, feel free to widen the discussion beyond methane now, because this applies to a lot of detections. Antoine.
Yes, so just to complement on what Stephen just said, clearly, it's just a journey. The bad news is, even though, the detection threshold of tropomy is pretty high, above, 5 to 10 tons per hour, we've still seen a lot of these leaks now. And we have engaged with tens of operators telling them that we've seen a leak. In 95% of the case, they've confirmed our detection and our evaluation of the flow rate. And now we are engaging with them because they know that they cannot hide anymore. So it's obviously, these are the big leaks only, and we'll have to go for the next, the 100 kilos per hour for sure. But today we have the way to engage with investors and with producers to tell them, guys, we've seen these leaks, this shouldn't have happened, what's happening? And investors are very keen to use our data to go to engage with their portfolio company and oblige management to do the proper action to eliminate these, huge leaks that should not have happened. There are many ways to eliminate these leaks. You can flare it, you can use it, you can, build the pressure down differently. So I think it's a journey, but the good thing that we have the tools to engage with investors and operators so that they start to understand that there is no place to hide.
That's good news. Let's widen the discussion a little bit beyond methane to the many things that you analyze. It's all about finding patterns. It's all about automatically figuring which beats need chemicals, to echo an important debate in France right now. Give me an idea of what's the state of the art? What's the most difficult jobs that you're handed? What are the detections that you wish your AIs could do today and that maybe they will do in 6 months that could unlock big markets, apart from trace gases in the atmosphere?
I'll jump in.
Yes, please.
As far as the state of the art for us, we get really excited when we have the ability to take some of this globally present data and use it as sort of that foundational element where then by combining regional and very location-specific data, you begin to really tell a fairly impressive story, and you start to see what the level of impact is beyond, say, a specific area, right? So the ability to take methane detection or synthetic aperture radar, looking at other things that can tell you what's happening over an environment, and then maybe even combining that with geolocation data or other things to understand how it's being addressed or what's occurring over that location. That becomes really interesting, and that becomes a use case that ties not only to a mining or an oil and gas company, but to the ESGs, to the nonprofits, to the governments. It starts to really branch out from there. So that's a really exciting when we get the opportunity to do that kind of work.
Antoine?
Yeah, so for us, our next generation of research is about carbon sequestration in forestry and biomass. So that will include SAR, high resolution optical, 3D, and LIDAR to be able to guarantee of the amount of carbon that is sequestered in forestry in particular. So this will be to fuel the offset market, which for now is based on a very weak way of guaranteeing that the carbon has been effectively sequestered in the forestry. So we look at emission, and we want to look at the offset to have a full environmental solution for the carbon accounting.
Yes, Stephen.
I just build on what was said. Is I think and Antoine said it earlier, and I just want to repeat it because I think it's incredibly important, about transparency. The revolution is in making the data much more transparent and understanding. And part of that, and I think this community is a great example of, but also recognizing what it can tell us and what it can't and how we move. So we talked about methane. MethaneSat measures CO2 as well. We focused on methane, but we'll have CO2. We'll have, as Antoine said, we can look at forests. That's actually what I've done for my entire career. So we're starting to build this transparency, which is a revolution. And we need to lead, and we need to bring everyone along with us, that basically, as again, I think I'm just quoting Antoine, you can't hide anymore. You still can hide. Some of the people are hiding because we can't see everything. But in just a few years, you won't be able to hide. You'll understand the patterns, whether it's forestry patterns, whether it's greenhouse gases from oil and gas, whether it's landfills, whether it's agriculture, whether it's N2O. There's a whole host of things that we'll be able to measure far better. And we're on this exciting inflection point for increasing the level of transparency. And in that regard, I think the oil and gas community, at least all of the folks I talk to, understand that.
And surprisingly, there was some discussion on transparency, previous panel on maritime domain awareness, where I think it was MSAT that said, we to be trusted, we want your algorithm to be a glass box, not to be a black box, because it's all about trust. However, I'm wondering, in a lot of cases, what you provide is business intelligence. It's not just the environment. There's people who want to hide there. You're up against the opposition sometimes. Is anyone out there starting to cover those parking lots where they don't want you to count the cars, starting to tweak the signal, find ways to spoof the AI? Does that happen? The suspicion is always there with AI, right? Or am I Gareth?
I think we would be very successful if we're promoting that sort of behavior, and so I would like to guess to get to that point. So we know we have been very, very successful in our impact, but we're at very early days of getting the big companies to recognize the impact that this data is going to have on transparency. Till they even think about being able to hide from it. So we have a few years, I think, but we can have careers in advising on that.
I see. Antoine and then Stefan, Germain.
Yeah, and it's a multi-source that, because we always combine different sources from geolocation, from tweets, from various satellite, SAR, and optical. And if one disappears, maybe you will degrade the quality of your signal, but you'll still see something. So I think it's complicated to hide completely,
Right. Stefan?
Yeah, I would add that we are actually seeing some operators starting to pay attention to when satellites overhead. And I would say that's not necessarily in North America or Europe. It's in other parts of the world, believe it or not. And we're also, keep in mind, all the instruments that are in space right now that can monitor methane and all the future ones rely on daylight. That leaves a lot of time to do things that you otherwise wouldn't want people to see. So there's definitely some awareness of that.
Another thing that our maritime panel said is detection is great, but can you also do prediction?
So
prediction of various things. Prediction of my dam is going to collapse. One of my favorites is prediction of trying to predict where deforestation will happen, not where it's happened last week when it's too late. Stefan, and then Stephen.
Yeah, so we announced a contract with Bloomberg almost a year ago, where we are actually providing exactly that, predictive analytics. Now, I will emphasize it's early days, and the algorithms get smarter as they get more data. But the intent is exactly what you're describing. So you take all the factors that led to emissions in the past and bring those together to predict where there's a higher risk and a confidence in that risk going forward. And we offer that as a data set today, and it's only getting better with time.
Good. Stephen?
Yeah, so I agree, but I think we have to step back a second. It's the question of to what degree is this stochastic and probabilistic? And many of the issues we're talking about, particularly with methane, there's a combination. Currently, most of the companies see it as stochastic. I think everybody on this panel would agree it's much more probabilistic. We just don't have the data to build the models. But there's always going to be a stochastic element. You know, things break, things happen, and they don't happen in ways that can always be predicted. But if we look at the airline industry, one of the keys is by using good probabilistic, we made it incredibly safe, right? I'm in awe of the engineers, right? They understood, they do root cause analysis. So it's important that we move to that, but we don't have the underlying data. We won't be able to do that fully from space because you need to know a level of detail of the equipment and all of it that we wouldn't be able to pick up for a long period of time. So we have to remember that it's going to be both on the ground and in combination with remote sensing that allows AI to pull those together. But there is a revolution ongoing, and it was nowhere 10 years ago when it just wasn't happening, and it will happen to a larger degree, but we're still at the beginning stages of that journey.
Right, and by the way, there's a lot of ingredients in the secret sauce, because one thing we've mainly talked about the satellite data, but there's all the ground truths, there's all the other sources that are coming into this, which can be as diverse as social media, regulatory filings, sensors on site, a million things, right? And a million things that can maybe go wrong, data sources that can be discontinued. Let me just throw one more. How often do you come across a use case where you find a substitute, you or your customers find a substitute for the satellite data? Gareth, and then Stefan.
So the question is when they find a substitute that they can use instead?
Among other things, because everyone is looking at all those sources that go into the multi-int kettle.
That's actually the really exciting thing, and I think for us particularly is the data fusion element that we've just been touching on. Is bringing all these sources together. We start to look at a future where Earth observation is just one element in a big, like, Internet of Things sensor network: ground to air, high altitude, space, and more above and beyond. Where we said more data, the better, not just from satellites, but to fuse this together. And then we've got to pin that to some real truth data as well. And we've enjoyed working with customers who are giving us their facility data, how much gas they're burning in turbines, power stations, to actually check that with the satellites, with ground stations, and bring that all together and bring all these sparse data sets together. No one data set is the solution.
Right.
There's this nice picture of a full data fusion model. I think
that's what it's about. Yes, Antoine, please.
Yeah, I think the way we see substitute is when we do asset monitoring for the operators themselves. So we do right-of-way monitoring to detect encroachment along the right-of-way along pipelines. And in that case, we are going to replace helicopters, planes, or people walking along the pipeline or the high voltage line. So it's a change of technology that exists, but we are just replacing. It's much more cost efficient. We've compared ourselves with planes, and we see 5 times more event and encroachment through satellite than plane. So it's a very effective. So it's a cost efficient way to do that. It's the same versus drones. I mentioned 3D reconstruction. We can do very, very precise 3D reconstruction at scale. And for now, you are going to replace the people with their tripods that are doing it once a year, and you can do it very regularly for safety reasons in mind and something like that. So it's replacing existing technologies.
In business terms, is it mainly on a project basis, or is it mainly bespoke products, or is there a nice flow of recurrent products for those verticals now?
So this is purely, we sell only recurring revenue. So we build something, and then it's a monitoring system that lasts for until there's a new technology.
Okay. Yes, Stefan, and then Stephen.
I want to speak again to the complementarity of data. I don't think there's, it's more that satellite is substituting for existing technologies that are already serving the markets, at least in methane monitoring, rather than the other way around. So, for example, we're building our own substitute, which is we take the same sensor we have on a satellite, we put it on an aircraft. I know EDF's done the same thing. And the idea there is that you actually get at different resolutions, different detection thresholds, complementary data that serves your customers and your end goal better. So I think it's normal and important that you actually use these multiple data sets to provide the best service to the customers.
I'm wondering also, using the example of pipeline monitoring, for instance, when engineers lay a pipeline, they already in their head integrate soil characteristics and land use and so on in their planning and doing geospatial analysis without always necessarily even knowing it. So in many cases, you're not really inventing anything. You're just automating and systematizing all practices, right? Or have you, in some cases, found any observables that are fundamentally new, or methodologies that are fundamentally new approaches to the problems that the pipeline engineers or whoever the agribusiness is tasking you with? Yes, Stephen.
I'm gonna actually want to step back. I apologize. I'm not going to answer that question.
Okay. Does anybody want to answer the question?
An important point we missed. Sorry, I'm just going to take us back. The issue of can you hide is really important. And so the answer is yes, you can, but no, you can't either. And the reason what I mean by that is this is going back to the ecosystem. By looking at a mapper and a target mode, because you leave plumes, even though you can't see at night, we'll be able to pick up the fact that there were emissions of greenhouse gases. We may not be able to be as precise. So the ability to hide is very limited. It's not zero, but it's very limited. And the key is by having multiple modes of analysis, multiple techniques, we will be able to see there's something going on and that people are hiding. And so that's critically important that we make sure that it isn't like, oh, you just modify your behavior and nobody will see you from space.
Right. And it's also hopefully not in their interest to hide, because they're wasting money, right? They're wasting their operations are not running as efficiently as they should for business reasons as well. That's hopefully what should happen. Gentlemen, we've covered a lot of ground, I think. Unless anyone has answers coming up to probably asked twice as many questions as we could answer. Or are we about done? Okay, I think you've conveyed some of the excitement of that field of activity. Where we look forward to seeing you again next year for a report on how that marketplace will have moved. Some of your satellites will have moved from the ground to the air. And for my part, thank you to our audience for joining us. It's been a great World Satellite Business Week. And I'm now happy to hand this over back to Lorraine and Pacom for the World Satellite Business Week Awards. Thank you and good day.